Hello students, welcome back. Now let's go to problem 3. This time we have mean but associated to actual sample. Previously, the problem did not give you the sample data because there are too many, 2,500 something. It's impossible to process. But here, the problem gave you the table. Here's a sample study, and how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 22. Let me count again. 4, 5, 6, 7, 8, 9, 10, 11. Yes, 22. So you can clearly see that there are 22. And this sample size is way too small to apply the normal table, the Z approximation. Typically, we want 100 or more for Z, at the very least, actually. About 30-40 years ago, that threshold used to be about 30. 30 or more, then use normal and then be done with it. But that was 30-40 years ago when the computing power wasn't there. Nowadays, less than 50, then definitely we are using the T, student T approximation, and greater than 100 we use normal, and then between 50 and 100 kind of gray area. And according to our current textbook author Sullivan, we are still using T even for greater than 50 in most cases. Here n is 22, so it's certainly less than 100. So, or even 50. So we're going to use t-test. Not z-test. We're going to use t-test. All right. Now let's set up the hypothesis. We made this observation. And then do the sample statistics such as the mean modulus of round trip exceeds 75. So that's something we have to test. It's all about 75. Not this one, not this mean. And this came from sample. So it's not null. This is the null hypothesis. This did not have anything to do with sample. So here we go. That's the null hypothesis. Mean is about 75. And what's the alternative? Well, exceeds that, so greater than 75. You can see also, look at the mean, 77.33. Okay, it's greater than 75, so clearly we are talking about greater than 75. And if the alternative hypothesis has been less than 75 and then this one turned out to be 77, then who would even bother starting any kind of hypothesis testing? So it's got to be greater. Okay, all right. And then let's test the hypotheses. In this case, we have to take t-test. So there's something you have to remember. What is the degree of freedom? Degree of freedom is n-1, so it's 21 in this case. And the reason we are subtracting 1 has something to do with this is single variate data. It's one-dimensional, so subtracting 1. When you have bivariate, there are occasions that you have to subtract 2, and so on and so forth, but that's not going to be covered in 1000 level stat course. So the degree of freedom for t distribution is n-1, so it's 21, and that is something you have to focus on in the t-table. Let's go to the t-table, by the way. Okay, t-table. Okay, here we go. And we have degree of freedom here. And in this particular case, we are focusing upon 21. So everything is associated to these numbers, associated to degree of freedom of 21. Okay, all right. Okay. So This is a t-curve, smaller sample size. Hypothesis, we discussed it. And sample statistic, here we go. Sample size 22 and sample mean 77.33 something, yeah, here. You can calculate all these, but you can save time. Mean is given, standard deviation is given. Excuse me, maybe I didn't give you that. Maybe you'll have to calculate all this mean and standard deviation using technology like MS Excel. Okay, maybe. If it has been exam, then of course I will give you the mean and standard deviation. If it has been in homeworks, many times I don't, and I ask you to go back and use technology to find out. Let's assume you're preparing for an exam, so okay, mean and the standard deviation are given. And the standard error, how do you get standard error? Standard error is standard deviation over square root of n, isn't it? And here in this case, standard error, standard deviation of 5.03, that thing, over square root of 22, yeah. And run your calculation, 1.07, yeah, that's basically it. That's the standard error, that'll go to the denominator. And the degree of freedom, we discussed it, that's 21. Okay, here's the initial picture. Again, t-curve and normal curves, z-curve, are pretty much the same unless you use really precise computing tool, graphing tool, and then look at it side by side or overlapped. If you use hand-drawn picture, you cannot tell the difference in naked eye. Okay, kind of normal-like picture here, and then null is 75 here. And then we got 77.33. Is it too far away from null so that alternative wins? Or is it close enough to null that null wins? It depends upon the threshold, the critical value, and let's find it out. How do you find it? Well, let's get this t-table, t-score. T-score formula is the same as z-score, n minus center over sc. But that has to be equal to appropriate t critical value. Here we go, n minus center over sc. Same formula, z-score, t-score, they're all the same formula, n minus center over sc. But where is this coming from? 1.721, what is that? We are using alpha value of 0.05. So here in this t-table, this probability, shaded probability, is alpha, and that is 0.05. So we have to look at this column here. Do you see this column, 0.05? And then go down, down, down for degree of freedom of 21. Do you see this? 1.721. That is the t-value that you're looking for. And then once that is done, finding x is an easy job. Just multiply this denominator, the standard error, to the other side. Multiply, and then if you want to, run your calculator. Or you can postpone it after flipping this to the other side, and you can calculate all this. If you do it, then you're going to get 76.84 something, less than 77.3. So what's the conclusion? In the picture you drew before, this unknown value is now determined, 76.84, and 77.3 is too far away from the null, so alternative wins. This method, in my opinion, is the best. It's quite logical to draw t-curve or z-curve, whatever, around the null, and then we are looking for the critical value based upon which direction, greater or less. And then how do you find it? By simple t computation and looking for degree of freedom, or z computation. Once you get the critical value, comparing that with observed mean, to the right, too far away, or to the left, close enough to null, it's easy to tell and easy to understand. Now let's talk about probability value method. No, hybrid method first. Hypothesis the same, sample statistics the same. And here's the initial picture. Instead of drawing it around the null, draw the standard t-curve around the origin, and then looking for critical t-statistic. Not the critical value itself, but critical t-statistic. So this is kind of corresponding to critical value, but it is already processed. The computation, calculate the t-score for the observed proportion, observed mean, and n minus center over SC, we get this value. And then from the same t-table, we get the t-statistic, which corresponds to the critical t-statistic here, which is highlighted in purple, and then compare. Greater than 1.7 something, that means really far away, red region, so alternative wins. It's okay to do this way, but both this t-bar and the t2 are processed values, so theoretically it's a little bit harder to understand, and that actually shows in whenever I grade, that additional difficulty actually shows up. So students do not perform as well if the student uses this method. But it's a legitimate method, and our textbook author uses it. How about the second method? This is going to be a bit of a problem because you have to have different tools. Not the t-table that I just gave you, but you have to have a little better calculator that actually calculates the p-value, the probability value for student t-curve. And that's not something many of the calculators can handle. So if you know how to use your calculator, if you can do it, and if you really like p-value method, go ahead and do it, but advanced warning first. So here's the initial picture. Outline, center, end, and shade. Center is 75, and then here 77.3. Okay, that's the observed proportion, and then you're looking for this p-value. How to calculate this p-value? All right, t-statistic, n minus center over SC, and we got that. But now it is hard part. How do you calculate the probability, the area of the screen region, by handheld calculator, because the t-table does not support it. See, the t-table does not support it. It gives you just critical d values. So how are you going to do that? And that's going to be a bit of a problem, but assuming you did it, then you're going to get something like this. Actually, there is another table in the appendix of our textbook that shows you some p-values of t, but it's really cumbersome to look at and very, very crude. So crude that it often fails, actually. But in any case, suppose that you got the p-value, then you can make a comparison. Greater than alpha, then null wins. Less than alpha, then null loses. And why is going to be a bit of a problem. It's a difficult question because they are related to the probability of type 1 error. But I don't know whether there's anybody who remembers all those conditional probabilities, or a lot of students must have even forgot what type 1 error was, even then. So trying to understand everything and getting it done is going to be difficult. But in any case, it is possible, and it's one of the legitimate method. Not that I recommend, but it's a good method anyway. Okay, that completes, and everybody have a good luck.